Let us consider one or two examples so that you can understand what you meant by impulse. Suppose a person jumping from certain height h from ground level to the swimming pool, and in another case the same person is jumping from the same height h to the ground as it is. First case and second case. Then in this particular case, that particular person will get more injured, and in this particular case the person will feel less injured. Let us consider one more example. A ball is coming in the downward direction and an athlete would like to catch that particular ball. In such a case, what happens? He would like to lower his arms during the catching process. Suppose he is not lowering his arms, then what happens? Consider another example. Suppose we have some glassware, like we are fixing this particular glassware for the windows, or maybe of something like a partitions, such kind of a big glassy plates what we are considering, or a delicate substance. Sorry. If you are trying to transport that kind of materials during the long run from one place to another place, then definitely it has to be covered with some straw, or it has to cover with something like a packing material. They at least want to use a thermocol sheet between the two glass plates so that a tight bonding will be happens. Why this entire thing happens? Fourth example, what is the role of a shock absorber in the vehicles? So all the things are doing as some interesting thing, that is nothing but suppose there is a large force of impact you are predicting, and if the thing will be happen in the very lesser time, then definitely we will feel some injury during this particular case. Now I want to reduce the injury effect. Then what I need to do? If I try to increase the time of action, then automatically the force received by the person will be decreased. As a result, impulse J going to be fixed quantity. So J is equal to, you can write down as F into delta T. So therefore, how do you define the concept of impulse? Impulse can be defined as the product of force in a shortest interval of time. Actual definition. But our convenience, what we did is practical purpose. We will try to increase the time of impact. As a result, force will get decreased. That's the logic what we are doing here. And the units and dimension formula, everything let us see. You can measure with a Newton second. You can measure with another quantity, important quantity, kg meter per second, with the dimension formula mlt power minus 1. However, this particular dimensions and units, these are matching with the linear momentum. Therefore, the value of J is equal to, you can write down F into delta T, which is also equal to change in momentum, nothing but final momentum minus initial momentum of the object we can write down. Now in the given problem, or in the given case, suppose if an examiner asks you about something about impulse, then how can you understand the concept of impulse in the problem? So as you consider force, momentum, both are vector quantities, and time is nothing but here scalar. A scalar can be multiplied by vector, there is no problem at all. But the result again, it will give us a vector quantity only. So therefore, it is a vector quantity. That means you have to take care in the form of a vector addition. Okay, second. Suppose if the examiner gives you in the form of a graph, what graph? Force versus time graph is given. Then in the particular graph, we have to take care the area. Area of the particular graph F versus T will give you impulse in the given interval of time. As a result, what are the application? You can determine the final velocity or initial velocity or mass, anything you can determine during the given formula. And next one, third one. So, how to find out impulse in the different cases? That means how to find out for a continuous function is given, how to find out the value of impulse. The value of impulse J is equal to, can write down as integration of can write down as FDT running over for limits T1 to that of T2. That means within the time interval from T1 to T2, the function of force is given to us. So the value of force is given in the function of time, that has to be substituted here. Upon doing integration within the limits of t1 to t2, you can determine the value of what? J. J is nothing but what here? Impulse received by the system. On the other hand, you can find out, you see here already given a vector, so is a conclusion can write down as what, f bar dot d bar can write down as with the sigma which is equal to j effective. You can take a vector addition, okay, ji running from 1 to n, fi and ti. We have to take this kind of form. Sometimes exam will ask you what is the average impulse. Sometimes they will ask you. In such a case, average impulse means what you write down, average in fourth one. So you can write down as J average is equal to, you can write down as F average into delta T. This is important. That means you have to find out the average force acting on the system, and then you can determine impulse corresponding to this particular case. Now, let us see the examples with some problems. Example problem 1. There is a projectile like this, which is projected with the initial speed of u at an angle theta. Find out the impulse during the total time of journey. Suppose they'll ask. Impulse is nothing but what? J is equal to change in momentum you have to take. Along the x direction, there is no change in the velocity. Therefore, only y direction only you can observe the impulse. As a result, you can write down as 2 into m into vy. You can write down, which is equal to 2m into, you can write down as since Vy and Uy finally both are magnitudically equal but opposite direction, in calculation of relative velocity we got the plus, therefore I used here 2 mu into, you can write down as sine theta. This is the impulse for the example 1. Let us take one more example here. In this particular example, now examiner given us a force versus time with some a graph like this, which is not exactly in the form of circle, but it may be any other shape given. Then limits are nothing but here t2 and this is t1, limits are given. Here the value is nothing but what, f naught, peak value given. Then it is seems to be in the form of a semi ellipse or semi form you can take. Therefore area J is equal to area of this graph. J area semi means half of the area. Ellipse area is nothing but pi into AB. A is nothing but semi major axis. Semi major axis means how can we take t2 minus t1 by 2, you can take t2 minus t1 by 2 into B. B is nothing but semi minor axis, nothing but F naught. So therefore you can write down as pi by 4 into F naught into delta T we have to take. This entire width is called as a delta T in the second case. Now let us consider one more example. Example 3. Now an object experiences a displacement versus time. The graph followed like this. This will be goes to infinity. Here angle alpha, here angle beta given. Given that x bar versus t. We have to find out the impulse in each cycle. We have to find out the impulse in each cycle. No doubt that is in the given problem displacement versus time given. So the slope of the graph gives us what? Velocity. So therefore this is the initial velocity and this is the final velocity. Impulse J is equal to change in momentum we can write down. So therefore mass of object is m into final velocity minus initial velocity, m into what is the final velocity here? Tan beta, and initial velocity is nothing but what you can write down? Tan alpha. Using this particular value you can determine impulse in the given system. Now, example number 4. Suppose here is the horizontal circle and here is the vertical circle. In the horizontal circle, object is moving with the uniform speed u and u like this. Object is moving uniformly in the given system. This is A, B, C, D given like this. We have to find out the impulse from A to B. In this case, we have to find out the change in momentum only we need. Change in momentum means mass is constant and change in velocity only we need. Change in velocity means these two are at right angle to each other. Therefore, we can write down as what? Root 2 into mv we can write down. What's the formula I'm using here, Nana? Parallelogram law for the determination of relative velocity. So change in velocity is equal to root of, what's the formula? v1 square plus v2 square minus relative velocity. So therefore, 2 v1 v2, what you write down here? Cos theta. Because angle between them is 90 degrees, cos 90 is 0. I got v1, v2 both are equal, therefore root 2 into b I can write. So similarly, I want to find out JAC. So A and C both are opposite to each other, no doubt, therefore you can write down as a 2mu, we can write down like this in the given case. Now, so let's consider one more case. Example number 5. Suppose because of wind, on a massive substance of M, a force F is equal to something like A plus BT newtons acts, where A comma B are nothing but constant numbers and T is nothing but some time. Then you have to find out the magnitude of the impulse between the limits of T to that of T naught to that of 2 T naught. What is the impulse between the T naught to 2 T naught interval? You have to find out. To find out this, we have to calculate impulse J is equal to integration of, we have to use FDT. Therefore, integration of, you can add on as here A plus BT into DT. Here in the given problem, limits are already given. So limits are given from where to where? T naught to that of 2 T naught limits are given. You have to do the integration between the two limits. Upon doing integration, what we write down is nothing but AT plus BT square by 2 running over from limits T naught to that of 2 T naught. So upon substituting the upper limit and bottom limit in the given equation, what you write down here? A of 2 T naught minus T naught plus b by 2 of, what you write down here, 2 T naught whole square minus T naught square, which is equal to 2 T naught minus T naught only can write down. Therefore, A T naught minus, sorry, plus b by 2 of 4 minus 1 means 3. 3 T naught square we can write down. Therefore, upon making common in the given case, take the LCM as 2. Therefore, 2A T naught plus 3B T naught square by 2. So, this is the change of, so this is the value of a change in momentum in the given interval of T naught, or you can take down this as what? Impulse in the interval of T naught to 2 T naught. Anyways, like this, we have so many kind of examples in the impulses. In the examination, they can give you, so for example 6. So boys and girls, this is the homework question for all of you. Please take care. Suppose here is the graphical representation of force versus time of impulse. I'm just giving like this. This is the value of T naught. This is 2 T naught and this is 3 T naught, and this is the maximum force. Now you have to find out what is the average force with this particular data. Okay, right. Thank you for watching my video. Please subscribe my channel for further updates. Jai Hind.